without further ado, I will get started. I'm going to be talking about async iteration in JavaScript. And I picked this because, like I said, I wanted to talk about something that you wouldn't find in a normal bootcamp curriculum. It's a little bit more of an advanced concept. It's also a concept that's extremely interesting to me. For the last 10 years, I have been thinking about what asynchronicity is as mainly a JavaScript programmer, and where my expertise lies. I know that async is one of the most powerful features of JavaScript and the reason why so many people use it and choose to build products and experiences with it. It's powerful, it's amazing. And number two, it makes writing code really hard sometimes. So I've seen kind of like the strategy of implementing asynchronicity in JavaScript kind of grow over time. And that's where what I want to kind of start talking about is what we've done as the JavaScript ecosystem, the JavaScript community over time to write better code that uses asynchronicity. So asynchronicity, just to get on the same page, is the feature in JavaScript where if we do something like input-output outside of the program, like a file read or a database access or transaction or a HTTP request to another server, we have in JavaScript the ability to let our code continue to run and calculate while a sub-worker or whatever the implementation might be handles the process of reading the file or accessing the database, and then reports back or signals back to our single-threaded JavaScript environment to continue. To say this work is done, and then here's the result, or this work failed, and here's the reason why. And for a pretty long time, we were just doing that with functions. Like we would do fsRead file, name of file, comma, here's what you should, here's how you call back to me when that file's been read, and then you can like put all of the reactionary code that needs the value of that file read inside of that function. And that's, ultimately it still does basically work that way, but we've really kind of evolved the ecosystem and the set of tools that we have to think about these things in better ways and to kind of manage and write better code in this way. So some of those things have been like event emitters, right? Event emitters we've all kind of like had for a while, right? Everyone does their first event emitter with like a DOM selector, right? On click, or add event listener click, or input, or key press. Maybe on jQuery, you select something and do .on. Those are event emitters. We've had those for a while, but they've never really represented like single operation things like a database read or a HTTP request. And then promises, that was like the big revolutionary addition. Becoming mainstream in the ecosystem between, I would say, like 2011 and 2015, implemented by libraries like Bluebird or a built-in promise library in Node, for example, and then becoming part of the language proper, a formal part of JavaScript as defined by ECMAScript back in 2015. The fact that we have an object that represents an asynchronous operation, something that's happening, and then can have handlers attached to it when that thing has resolved, or even if something asynchronous wasn't happening, you can still resolve a value asynchronously. So you don't care if something came from a network or a cache, right? And you can represent that operation completing in a uniform way. Promises are what is driving all of these other evolutions that we see. The biggest one, I would say, recently being async functions. And async functions, wow, they are amazing. They're like, they let us write code that does asynchronous work and parallel work as if we were just writing in a platform that would block, right? Like Python or PHP or Ruby. You open a file access and you read the file, and your program just stays on that line until the file has been read and then continues. And that's, if you want to do parallel stuff in PHP, that's kind of a bummer because you have to open up new threads per worker for like per HTTP request or something like that. And you really can't read 3 files from the same PHP program without doing some thread management. So to get asynchronous properties and write our functions as if they were from other languages with like pause on lines and blocking operations and async functions giving us to that by leveraging promises, we are in a whole other like zone and world of asynchronicity and writing JavaScript code. And JavaScript code is just because of this become so much easier to write. But what really leads me here into wanting to talk about this is I think that we're still evolving on how we can think about this. Now that we have async functions and that promises like proper in the language to be used as the fundamental units of these strategies, there's new stuff coming, and I think this is one of those new things, and it's pretty exciting and interesting to think about. So I wanted to show you those thoughts and how that works. So what I'm talking about here in this lesson is async iterables and the statement for await of. So this is a looping statement in JavaScript as implemented in, I think, 2018, or at least spec'd out in 2018, and I think is now fully implemented in latest version Chrome and also latest version Node.js, or LTS version Node.js. So you can just do this now, but it is a really modern feature of the JavaScript language. So before we can talk about async iterables and for await of, we have to talk about normal iterables and for of, the for of loop. So many object types, what I mean by object types here are things like strings, maybe, arrays, node list when you do DOM selection, the arguments object when you call a function. Many object types in JavaScript now come equipped with a key entry on them that is the Symbol.iterator key. So the Symbol.iterator key is it's just a static property off of the symbol class, and it's reserved for object structures implementing the iterable protocol. I will clarify what I mean here with code. The value of this key is a function that should return an iterator object, and what is known as an iterator object that follows the iterable protocol. And that is that the object has a next key on it that's value as a function, and that function, when invoked, should return an object with a value property and a done property. And then the done is a Boolean, and the value is whatever value is being yielded by the iterable. Iterator objects are meant to combine with the for of looping statement in JavaScript. But they can also be used or accessed directly as well. But the for of statement in JavaScript intends to work off of any object structure that has implemented its iteration strategy through the Symbol.iterator key. So I'm going to take us over to the REPL so that we can kind of explore what's going on here. So let's say that we have an array of values. So just so that you get to know a little bit more about me while learning about iterators as well, let's set up an array of Joe's hobbies. So I'm a drummer, love music, play music, mostly drums. I do a lot of programming on the side. I spend a lot of my outside of teaching free time working on games in Unity and C# lately, and building mods in Unity, but I also am doing lots of game development mostly in my free time with JavaScript. So I would say I am a programmer by career and hobby. I love to do it. I also love to play games, build games, play games. Yeah, let's just, let's get back to it. So that's an array of 3 strings, right? And we have all kinds of ways that we've looped through those arrays. We can use a for loop. We can use a while loop. We can do Joe's hobbies .for each, or .map if we want to transform every value into something else and then put that into a new array. Lots of ways that we've probably gone through arrays before. Let's talk about for of being one of those ways. So we can say for let hobby of, be careful to put of here, not in, of Joe's hobbies. And then we can console log it out. And there we go. So we have yet another way to loop through an array. But let me show you what is actually lying underneath the surface here. So any array that you create in JavaScript with an array literal, like I did in this case, has a key on it that is accessed with the symbol, the iterator symbol from the symbol class. Symbols are weird. I always think of them as like runes. That's how I imagine them. Like rather than like a bunch of text that shows you where something on an object is, you have like access to a shape or a rune. And you can use that rune to access something on like an object, but only if you have access to that rune. And this rune is given to us globally off of the symbol class. Anyway, you can look that up on MDN. Use it to access this key, and that'll give you a function. When you call this function, you get an iterator. So let's put that iterator onto a variable so we can reuse it. Const. We'll just call it it. Okay, so now we have that iterator, and we can say next. And this method next is part of the iterator protocol, right? Like anything that's being said is an iterator is kind of activated by this strategy next, or this method next. It should have this function here. And you call next, and every time you call next, you get back an object with a value prop and a done prop, or key. And the value will be the value being yielded from the iteration, and done tells you whether or not we're done iterating. So doing this one more time on a 3-length array, we then see undefined and then done true. And then anytime we use the iterator after that point, it's like, okay, no, I'm done. Like I've already kind of like yielded all the values that I was meant to iterate over this structure in particular. And this is what for of uses. For of kind of accesses this iteration strategy of saying off of this structure, what is its symbol iterator key? When I invoke that, I should get back a function that, or an, when I invoke that, I should get back an object with a next function on it, and then if I call that next, it'll give me the value. So let's see iterator being used off of a different structure that's built in, like a string. So, my name is Joe Alves. Nice to meet you. Apparently I already had a variable called name, so I'll say my name. So my name is Joe Alves, and this is also a structure that implements an iteration strategy. And we can access that iteration strategy by looking at Symbol.iterator. You can see that that's a function. When we invoke this function, we get an iterator back. So I'll say name iterator. Cool. And then if I call this name iterator and say next, I'll get Joe or J, and then O, and then E, and then a space, and then A, L, V, E, S. My name is Joe Alves, and then that's it. It's done. And this is a way that you can iterate through a string. And this is why when you do for let character of, not in, of, my name, which is a reference to just the string that is my name, not any of the other stuff that we put up here, I can then say console log character. And that's why I see all of those things being console logged that way. Because the for of loop acts against these iterators, these implementations of the iterator strategy. And we'll find it on all kinds of things. So I'm in Chrome DevTools. I'm on some site. I'm going to go ahead and see the site that I'm on right now. I think it's GitHub. I'm going to go ahead and query selector all for some divs. So query selector all div, right? And this gives me back what is known as a node list, right? So I'm going to say node list is equal to that operation, query selector all for all the divs. And this is what my node list looks like. My node list has a length. It is not an array. It looks like an array. It implements like keys as indexes, like an array would. And it's the kind of thing that we can use the array from static method to turn into a real array, but it's not an array. But we can use for of with this. So let element on page of, not in, of node list. And then we can say console log element on page. And then we see a whole bunch of console logs of those things, right? So our for of loop works with the node list, but we can also see one more time, like we did with arrays and strings, that's because if we look at the symbol iterator key on node list and then invoke that, we get an iterator. Too many variables. It's next, 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 and you can see each one of these is a different one. And we're not going to be done for a while. I think there's like 1600 or 2100. I forget what the number that it was shown here. 244, way lower than I thought. But still, I would like say next, 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 next. And this is what for of uses. This is what for of uses. So when you are using, so back to our slides now. When you are using a built-in type, it might implement the symbol iterator strategy. And then that is meant to kind of operate alongside of for of. That's what for of kind of like does under the surface, is it looks for symbol iterator, calls that, expects an iteration object back that it can call next on until it sees done true. So one more time with arrays, let's say you have an array of rangers, Jason, Kimberly, Trini, Billy, and Zach, the original 5. Arrays have a built-in iteration strategy, so we say symbol iterator, invoke that, and then we get back an iterator, and we can call the iterator multiple times to get each value from that array until we get a value undefined done true off of the last invocation of next, and then that combines with the for of statement. So that's cool. Like just in and of itself, without thinking about async stuff, I feel like knowing this is cool. I think, and like kind of like seeing what's going on underneath. But you can also create your own iteration strategies depending on what you want your structure to do, which is awesome. So the symbol iterator function can be added to any object that you have, or any structure that you have that you can assign a key to, like a string. And it can define how it should operate as an iterable, and then therefore combine with the for of statement. Generators are functions that return iterators that yield values per next call. And I'm not going to get like too deep into generators in this presentation, but I'll be mentioning it a couple times, because generators are functions that essentially return iterators, right? And then iterators, when they call next, allow the generator to like try to hit its next yield or return statement. And that's why async await works, but that's for another lesson. And iterables and the for of loop, in my opinion, are awesome because they allow JavaScript coders to have like a common interface for addressing each element in a sequence, right? Whether that sequence is an array of elements, whether that sequence is a string of characters, whether that sequence is a node list or an arguments object or a map or a weak map or a set or a weak set, to bring in some of those newer ES6 data structures. And you can just do for of on it, and then for of will use the like ideal iteration strategy as defined by the type you're iterating over, like how a string or how an array wants to be iterated over. And it's interesting, by the way, because something that doesn't have an iterator built in is just an object literal. So let me show you back in DevTools. Let me clear this out and then tell you a little bit more about me as a person. My name is Joe. I live in New Jersey currently, also like always, my whole life. What else? My favorite games. You know that I'm a gamer. My favorite games. I play a lot of Super Smash Brothers. Love it. And one of my favorite games that I build mods for, it's been like a big inspiration for me to learn and use Unity and C# is a game called Risk of Rain 2. I highly suggest you look it up. So that is me. Oh, I already have this variable, so let's just say Joe. So that is me. And that's some stuff about me in an object. And let's go ahead and see what happens if we have for let, what is this, of Joe. And if we even just write that statement, it tells us, type error, Joe is not an iterable. What JavaScript is telling us here is that the for of statement tries to operate on its right-hand operand, right, as a iterable. Specifically, what it means is that the object structure as its right operand should have a symbol iterator key that will give us back the iteration strategy. So if we look at Joe and then try to find this symbol iterator key, there is none. Object literals don't have an iteration strategy built in JavaScript, but we could make our own. So there's lots, I think, of things to think about here. So this is going to be kind of like a naive implementation just for time. But what we can do is we can say symbol iterator and assign that key to a function. And this function, as we've said, needs to return a iterator, a object with the next function to be called. So I'm going to say that there is going to be a next function that I'm going to be building. This will be called by the iteration strategy or the iterator. And then let's also set up the actual bits. What are we going to yield per iteration? So I'm going to use like I said, there's lots of ways of thinking about how to do this, including what if keys get added later or before it's completely iterated through. So this is going to be sort of naive, but I'm going to use the entries static on the object class entries here, and then pass in. I can either pass in Joe or this, assuming that that's how the iterator is going to get created. But we can just pass in Joe, because this is just for Joe, not for all objects, let's say. And this will give us back, if you don't know what entries gives you, it's an array of tuples. So it's an array, and then each tuple is the key and value, or entry in the object. So having those entries that I am going to access via closure when I make my iterator, what's going to happen when I call next is either I'm going to say, if my entries length is 0, meaning I've already iterated through all of my entries and there's no more entries for me to share, I'm going to say that my next function should return an object with value undefined and done true, right? I am out of entries or values to share with you. Otherwise, right, we can say, okay, let's return the value being entries shift. So I'm just going to pull off the front of the array, and it's a mutable operation, but it's pretty safe to do that here. So we're going to shift off the front of the array, one of those tuples, and then also say we're not done because there might be more. And now we have our basis of what our data is. We have our next function, and the whole point of the symbol iterator function when it's invoked is that it should return an object with a next function to call. So we can say return next or use object destructuring and do that. So if I've done that correctly, what I should be able to do now is, for example, go ahead and access that. And this isn't actually anything special that JavaScript is doing. This is just me following the protocol and then using the protocol. So I say, Joe iterator here, and then I can say Joe iterator next, and that should get me whatever the value should be. And then here's one of those tuples I was talking about, key and value, and then next, another one of those, next, another one of those, and then finally done, right? So like I said, this is just me doing this, right? Here's a function that returns the next function, right? But now what I can do is I can use for of, because this is what for of is looking for. For of is looking for an iteration strategy. I just built my own here. and I know that it would work. So like we can say for let entry of Joe, right? And now the symbol iterator key is going to be looked for on Joe and used by for of. And then I can say, what does an entry look like? And then I can even use in this expression array destructuring if I want. Since we have these tuples, and we can say key value, and then we can say, you know, console group key, and then console log value, and then console group end, right? And now we have something like that. And now we just have a way to iterate through objects. And this is, you know, like I said, there's a lot of things to keep in mind here with this like specific object iteration strategy. There's a lot of like kind of naive choices here, because what if like a key is added to the object before our iterator has been completely consumed? But this is awesome, I think. I think this is really awesome. So cool. That's iterators. That's iterators in JavaScript and the for of loop. And all the iterators we're talking about here are synchronous, right? They represent like values that come in without like in time, right? Directly we can think of, without having to go through any kind of event queue or kind of like function callback system, like what we would see with promises and all that stuff. Synchronous values. So let's talk about now async iterables. So regular iterables, what we just talked about and saw, that was like an ES6 thing. That was a 2015 addition to the language. So it's been around for a while. I think they're going to get more popular, or like a more like kind of direct strategy for more people as time goes on, because it is such a powerful pattern. But async iterables are newer. Async iterables, and then also the usage of this thing called for await of, are definitely like kind of like compounding strategies and topics that are like kind of being added on top of async await, and the fact that promises are now in the language. So let's go through what an async iterable is. So async iterables work similarly to the normal or synchronous iterables like we've been talking about, but promises are used as their operational unit. Meaning like promises and the objects that like kind of represent eventual results of operations are kind of being used at like every level of this, just like they're used for async await, right? So similar to leveraging of promises for async functions with await, right? Async is just powered by promises. The iterable protocol is actually the same. It's just an object with like a next function that you should call. But in async iterables, when you call next, you're always going to get back from next a promise, not a value directly, like the generation of the next value, but a promise that represents that a value will be generated next from that iterable. And then that promise will either reject an error out, or it'll resolve to an object with value and done, like what we're learning to expect from our like iterables. So unlike symbol iterator, which we saw on strings, which we saw on arrays, which we saw on node list and arguments object and map and set, and you can look it up, all those things that are available for symbol iterator, there are actually no built-in structures right now in JavaScript that implement a async iterator key. And this is at the bottom of the slide here. This is from MDN, and it says there are currently no built-in JavaScript objects that have a symbol async iterator key set by default. However, what we G streams, what WG, I forget what WG is specifically, but it's somewhere in the specification of how like a browser should work with JavaScript. So streams are something that we should expect soon in browser JavaScript code, probably to represent like things like HTTP responses, which come in chunks or streams, or maybe some other things. And that is expected when it does land to have an async iterator key built in, which would be the first structure native in JavaScript to have async iterator already implemented. But what we can do is we can implement async iterators ourselves right now. So I want to take you through an example. Let me go on over here to VS Code. And I'm going to take you through an example of a async iterator and how we can like implement and use an async iterator. So let me tell you a little bit about my family. So my family has 3 members. It's myself, Joe, my wife, Alyssa, and our dog, Penny, who is a year-old Havanese mix. And that's my family. And what I'm going to do is I'm going to build kind of like a, it's a classic, you know, like beginner's like kind of example where it doesn't feel super real world, but we are kind of like extrapolating what it could mean. So I'm just going to build an async iterator that just essentially gives back this data of who's in my family and what the members of the family are, but with a second delay. Before each of those things is available. And we can imagine that that second delay represents us like getting this from a server, for example, like from different URLs or from a database or something that takes a while, like a file read, something asynchronous. We'll just put in a delay for today. In order to like have like a delay promise, so something that represents like eventually a second will pass and then we can move on, I'm gonna create a quick delay function that returns a promise. So this delay function, I'll pass in milliseconds, and then I'll just return a new promise that will resolve after that many milliseconds. So I can just say set timeout, we'll call the resolve function from the promise executor, the constructor function that we specify. And that's it. So that allows us then to have a promise that will say, I will basically resolve after however milliseconds you passed into me. And we can use this as kind of like our HTTP takes a while, or whatever you want to think of there. So now what we can do is we can build a structure that can be used as an async iterator. So I'm going to say that this is like family members slowly is equal to an object that is now going to implement the symbol async iterator key. So this is what it's all about. Just like when we had symbol iterator, and that was like, here's a structure like an array or a string, whatever. Here's the iteration strategy through that structure. We're saying here's a custom structure that I'm calling family member slowly. And then when it's used in an async iteration strategy, like with the for await of statement we'll talk about soon, this is its strategy. This is what it should do. And just like our other iterator that we built for the Joe object, this needs to return an object with the next function. So I'm going to say here is an object with the next function. And the idea here now is that you can not return objects with value when done, but instead return promises that resolve to objects with value when done. And you can base this off of like whatever sort of like strategy you want. So what I'm going to do is I'm going to move this family array down into the function that is being invoked as the async iterator, which we'll see later, and use that as the data set, and then say here either family length is equal to 0, and then we'll promise resolve a object that says value undefined or just doesn't include the key, and then done true, right? And this would mean that like we don't have any more family members to yield out of this iterator, out of this iteration strategy. So we're done. So here's a promise that will resolve to an object that says we're done. Otherwise, we are going to say, let's delay for a second, right? As just to kind of mimic us like going and getting this data from somewhere or something. And then, and every .then off of a promise returns a new promise. So we're returning a promise here still by calling .then. Then we're going to yield, in a way, a value, iteration value, which is represented as these objects value, and then we can say family shift in order to mutate and grab members off of this array, and then done false. All right. And that should work as our async iterator. So what I'm going to do is I'm going to now use this a little bit, right? Here's my async iterator and what it should do. So now I'm going to write some code that uses and accesses this. So I'm going to say my slow family iterator is equal to family members slowly symbol async iterator, and then invoke that function. So this expression here gives us this function, right? And then we invoke that function, and what we get back is an object with a next key, which is equal to this function. And then what we can do is we can say slow family iterator dot next, and every single time we do that, we will get a new promise back. So we can do a couple things with this. We can kind of think about this in a couple different ways. So we're going to say Joe, or we can call it accessing Joe. It's a good way to name promise variables is with the present participle, right? The ing. And then we can say accessing Joe dot then, knowing that that's a promise, and then console log out that value. So we go ahead and say node async iterator. Wrong directory. We need to be inside a demo. Node async iterator. And then we get that value, right? What we expect. And every time we call next, we should get the next promise that's yielded by this async iterator. So if we were to put accessing Alyssa, accessing Penny, similarly underneath these lines, each of these lines would return to us, or each of these invocations of next would return to us a new promise, which is cool. That's awesome. And now we can also kind of think about how this can be cleaned up. Rather than using promises directly, you can even see VS Code kind of suggests this may be converted to an async function. So yes, your next function, your next iterator with async iterables can be async functions. So we can say async function, right, which allows us to use the await keyword, which might, if you're not very comfortable with promises, clean up some of the promise usage here, since we have this async thing, which is so awesome. So we can say here, await this delay, rather than thenning off of it, and then take this expression, unnest it, and then return here, right? And that's the same logic as we had before, but now we're not using promises directly. We're using them kind of under the surface by leveraging async functions. And this should work similarly to what we saw before. Let's go ahead and see what accessing Joe is not defined. That's right, I got rid of that line. So I'm going to say accessing Joe is slow family iterator. Next. Cool. So still working that way. And now we can talk about why you would have an async iterator in the first place. And that is for await of. So it is the corollary to for of with normal iterators. So let me go back to the slides. We can talk about for await of. So here is essentially the code for our demo, right? Where we kind of set up this symbol async iterator. We can also refactor it to be not using promises directly. And then once we have something that implements the async iterator strategy, like a structure that says this is what should happen if I'm iterated over asynchronously, either directly like what we saw before, or with this thing called for await of. So the for await of It's a statement that can only be used inside of async functions. Think of it because it says await inside, right? And you can only use await inside of async functions. And it activates against both normal iterables, which is useful. So if you did for await of on like an array, it would work like for of. But it also operates on structures that implement the symbol async iterator strategy. So it accesses next on each of those iterables as each either value is accessed off of the iterable or promise is resolved off of the last access. So basically it'll say, I'm going to call next, and then if I get a promise back, wait for that promise to resolve, and then call next again. That's how for await of is kind of thinking about how to yield and then continue to yield things from a iterator. So it gives us the semantics to iterate over a sequence of asynchronous operations or events. So let me show you in the code that we've been writing. Back to VS Code. What we can do now with this family member slowly object that we've implemented is use the for await of loop. So I'm just going to set up a async immediately invoked function expression. I heard that some people call these Yaffes because you have the A in there, IIAFE, Yaffe. Learned that pretty recently. So what you can do now inside of an async function, like this immediately invoked one, is use for await, and then we can say like let family member of, not in, of. I made that mistake too many times, that's why I keep mentioning it. Family member slowly, like that. So even though family member slowly takes like a second to like kind of come up with each value that it can yield because of this artificial delay, our for await of is going to allow us to like iterate through that sequence as each one becomes available and then move on to the next, which is like really, really awesome. So let me show you. So family member, notice the typo here, family member. And then just for kicks, let's look at date.now, just to know like how long it's been since the last iteration. So then we can call that, and we can see that output with that timing, right? So we can see Joe, and then here's our timestamp, and you can see it ends with 2467, and then the next one of Alyssa ends with 3469. So it takes about a second and then some change processing time, I guess, to move on to the next one, the next iteration. And this is a way of basically controlling a loop in your function off of a sequence of asynchronous operations that kind of like lead to the next one. And like, whoa, like this blows my mind. Like, I can't believe we're here. I really can't believe we're here with JavaScript, kind of coming from where we've been before, where we can now, using async and using the power of await and promises, think of things like in this way. So kind of getting back to like kind of the point here. So let's not imagine that we had like a delayed function that just spit out my family members' names. Let's think of it instead of being like an HTTP response, right? We know that HTTP response comes in as a stream. That's the reason why when we do use fetch, right? We do fetch and then we say like, oh wait, fetch. And then right after we say like, let data equals response.json. That response.json, and the reason that's asynchronous is because the way HTTP works is it comes in chunks. It comes in as a stream. If you've ever implemented like receiving data on the server side without express parsing middleware, but like doing it like on data, it comes in as a stream, comes in with chunks. And what we can do in JavaScript now is if we have an async iterable that represents those chunks of data coming through the HTTP stream, we can do something like in that first code block up here, where we use the HTTP response data stream and like, access it. We kind of like access it per chunk, then we like process that chunk. So what if we were like building also like a PvP networked game in the browser? What we can do is we can represent our like player input from the network. Basically, if we're thinking about like a two-player game, this would be the button presses from the other player that we want to recreate in this game client. We can say for await and then like kind of like use the iterator as like a long-term generation of that stuff. So you can imagine like a socket as a way of doing this, right? Like this is essentially like listening to a socket. And you can see if you've ever used like RxJS or observables, async iterables give us a lot of the like mindset of that too, by the way they work, by allowing us to represent a sequence. And then like, what about if you are querying 10 million rows from your databases, right? You might want to do that in like batches of like 1,000 or something like that. So if you have an async iterable that's going through those batches, you can just write a for loop, a for of loop to just gain access to it. It's just like, this is something that I'm like trying to explore more because I like kind of see the power and like awesomeness here to kind of solve different problems in a really like nice semantic way. So some final important details to understand about these things. So most of the time you still want to use promise.all when you're coordinating parallel operations. This is really important to understand. You might think that for await of kind of replaces or would like be a parallel strategy for combining operations that are all happening at once. It's not. I would say that for await of is more a use case for sequences where like the sequential operations that are asynchronous either depend on the previous, right? So like you want this operation to finish and then maybe it shares information with the next one, or they're all coalescing to some like value over time or like growing as opposed to like just like things that are happening at the same time that all need to be handled as a reaction. I also want to comment that the easiest way to create an async iterable is not to implement the symbol async iterator key, although that's like the key, like that's the core concept that you need to understand fundamentally to like kind of get what JavaScript is doing. The easiest way to generate an async iterable is to use an async generator function. And like I said, generators are very involved here, but also can be ignored, and the concept should still come through. Generators are very, like that's what you would want to learn next step to kind of understand how to use it and the powerful semantics we get from this. And then the purpose of this feature is to improve the semantics of your code. Just to be clear, like you're not using for await of to solve a problem you couldn't solve in a different way before. Just like promises don't solve anything that like callback functions couldn't solve, but also are like a powerful language construct that we can now write more manageable, organized code. That's what for await of is. Like it's a way to make your code more semantic and make working with asynchronous data or operations more manageable, aka just to write great programs. So yeah, that is my presentation on async iteration. Like I said, I think it's a continuing story of asynchronous JavaScript code. There will be many evolutions in the future, but hopefully you learned something.